In this lesson, we're going to apply our knowledge of math terms for operations and parts needed to create algebraic expressions, such as terms, variables, coefficients, and constants, so that we can translate words to algebraic expressions. You'll know you've got it when you score an 85% or better over the assignment on this lesson. So just to recap, an algebraic expression is made up of terms, and at least one of the terms has to have a variable in it to be algebraic. These terms will have coefficients, variables, and constants. So the example would be 3n plus 9. 3n is a term and 9 is a term. 3 is the coefficient of the algebraic term 3n. N is the variable, and when you put that together, it's 3 times n, which forms one of the terms. The other term is plus 9 or positive 9, and that is a constant. So these two terms together make up the algebraic expression 3 times n plus 9. And something to note is that when we are writing algebraic expressions, there's proper algebra notation for how we write multiplication and division. You need to always remember when you're entering your expressions to put your final answer in proper algebra notation. If you don't do that, it will not give you full credit. So we do not use the x for multiplication in our algebra world when there are variables in our math. We take that out of the problem, and it's confusing because it looks like a letter. And we simply drop it, and we write the number next to the variable, and it means 8 times y without a symbol in between. That's how it still reads. And we always put the coefficient in front of the variable for that term. So coefficient followed by variable. So no x's, as you can see here in some of these examples, no dots, no symbols are necessary when we have a number variable combination. It implies multiplication without the symbol. For division, we use a fraction bar instead of the symbol with the dots. That just simplifies our expressions as they get bigger and bigger, and it makes it an easier read, easier to follow order of operations. It's just a nicer way to write your division. So when you're entering your expressions for division, you're expected to put it in the form of a fraction. So algebraic expressions that have multiplication, 8y means 8 times y, and then algebraic expressions that involve division are divided by 6, use that fraction bar. So to start, we're going to translate these algebraic expressions that are given to you across the top here. We're going to translate them 3 ways into word form. So we're going to translate these given algebraic expressions 3 ways using words. So they're given to us mathematical notation, and we're going to translate them into words. And these are all one operation algebraic expressions because they all contain one operation. This one has a plus sign, this one has a minus sign. This has no symbol, but what we just reviewed, it means multiply. So this is a multiplication problem. This is the division. We just reviewed what the fraction bar means. And this is exponents. So they all have one operation to them, and we're going to translate those. So one operation expressions. So here we go. When we see the variable, we're going to replace the variable with the words a number. So when you see a variable, you're going to translate that variable as a number, and then we're going to translate the operation symbol. There's many synonyms for these symbols. You can pick whatever you want, and then we're just going to type the number out. So the first one is a number. That's what we have for the variable. Get my typer working here. A number. I'm going to simply say plus 2. You want to write neatly so you can read your words. A number plus 2. And then I'm going to translate this 2 more ways. How else could we say that same thing where if someone heard it, they would understand that we're adding R and 2 together? The second one would be a number. I'm going to do actually the sum of a number and 2. That is the synonym for the one above it. And another way you might say it is, hey, we're going to start with, we're going to say, hey, 2 added to a number. That could be a third way to say it. So how would you read that expression? And how are 2 other ways you could read that expression using synonyms for the first way you read it? So that's the goal here, to be able to translate each of these algebraic expressions using different math terms for the operation of addition. This one, we need different terms for subtraction. And then this one, we need different terms for multiplication, division, and exponents. Okay, so this one, when I see this problem, my first thing pops into my head is 3 minus, remember we're not going to say g, we're going to say 3 minus a number. That will be our word translation for variables, a number. Pretty simple. Okay, and then the next one, I'm going to think, well, let's see, if I'm subtracting, I'm finding a difference. So I'm going to say the difference between 3, and a number. Difference is the answer you get when you subtract. And when you're doing subtraction, you are finding a difference between the 2 numbers. How far apart are they? And then the next thing is, let's see, I've got minus, I've got difference. How about takeaway? 3 take away a number. Very simple way to translate those. And you have your 3 different synonyms for subtraction. Okay, now we got multiplication. And so when you're looking at this one, I think most of us would probably read it as 2 times a number. That's probably the way we would mostly just read it out. Whoops, I forgot my S in times. 2 times a number. And then we got to find some creative ways to say the next couple of them. Well, if I'm multiplying 2 numbers together, I'm finding a product. You guys got to know that word. The product of 2 and a number. That's a key word, product. You're expected to know that's the answer to any multiplication problem. Okay? And then finally, I might do something like double a number. Because it's got a times by 2, that means we're doubling. So double a number, you could say twice a number. That's another translation or synonym, and that would work just fine as well. Okay, now we're dealing with division. And when we read this, hopefully you see very simply that it could be 8 divided by a number. 8 divided by a number. We're taking 8, we're splitting it into equal size pieces. All right, and then we could say, well, we've got sum, we've got difference for subtraction, product, multiplication. So the answer to a division problem is quotient. So why don't we just keep that pattern in this row too and say, hey, what's the answer to a division? The quotient of 8 and a number. And then the last way, well, since it's division, we are splitting things into equal size pieces or equal number of groups. So we'll say, how about 8 split equally a number of ways. That would be one way to do the division as well. All right, and now we got this exponent over here. So the exponent could simply be c, which is a number, raised to the 3rd power. I'm going off screen here. Hold on, I'll shrink it down for you. Because that's what we're doing. We're raising c to the 3rd power. So we're taking any number there, and we're going to raise it to the 3rd. That's that 3. It's following the word third now. That's the word we're using. 3rd power. And then another way we say that is that special word cubed. So we'll say a number cubed. And another way to think about it is when we expand this out, it's C times C times C. So we could say a number, get my cursor down here, a number multiplied to itself. I know I'm going off screen, I'll fix it in a minute. 3 times. Number multiplied to itself 3 times. So those are translations, all good ways to say the same expression. And you need to be versed in different ways you need to have all these synonyms in your wheelhouse when we're doing these translations. Okay, on this piece of the lesson, we're going into 2 operations. So we're translating these following algebraic expressions just 2 ways this time, although there are many ways we could do it. And the first one has 3r minus 2. Remember 3r, there is an operation happening here, so we should always include it. It's 3 times r minus 2. So that's how I would read it if I were looking at that straight up. So 3 times a number, remember that's what we're using, minus 2. So we got to think of another way to say that. So we have to translate this first term again, and I have it as 3 times a number. I'm going to replace that with the product. And I'm going to change that up. I'm going to replace it with triple. Since I'm multiplying by 3, I'm tripling a number. And then after I triple the number, because I'm going to do that first, I'm going to triple the number first, then take away 2. So triple the number, then take away 2. So that should help to understand that this 3r should be coming, order of ops should be happening first. All right, so we've got that translated. Now we have this one right here, and we have a 9, 2 terms, a 9 and an m divided by 4. So to translate that, how I would probably read that straight up, again, just what is your gut when you see it? How would you read it out loud if you had to read it out loud in class? It would be 9 plus a number divided by 4. That's how I would read that if I had to read it out loud to you guys initially. And now finding a second way to translate that, I would probably look at that and just kind of think, well, I'm adding 2 terms together. I'm adding the 9 and eventually the m plus 4 to m divided by 4. I'm adding those 2 terms together. That's a sum. So I think I would probably approach the next translation, a synonym for the one above, as the sum of. Whenever you have addition, you can say, hey, I'm going to sum 2 things together. The sum of 9 and m, which is a number, split equally 4 ways. That's another way you could have translated that. How did you translate it? Might not have used the same way as I did, but hopefully you have division words and addition words going on in your translation. Okay, the next one has a multiplication and an exponent. So we want to put that piece together. And I guess I'd just start off, I would read that out loud in class as 3 times a number squared. That's how I would probably read that if I had to read it out loud in class. And then if I had to think a little harder on it because someone already read that one, I'd have to say, well, I'm multiplying 3, and when I square that, whatever that g is, I'm going to multiply those 2 pieces together. So that's a product. The product of 3 and g, which is a number, I'm going off screen. I'll bring it back over. A number to the second power. Oops. These are getting long, right? It's a good thing we have math notation because it's a lot shorter. As you can clearly see, the algebraic expressions above are a lot shorter than the word forms below. So that's why we have algebraic expressions, is to condense things down into smaller compartmentalized things that we can work with. So we don't have to have all of the word forms going on. Math translations. Okay. All right, so a lot of the times we just translate the math symbols into word form, and I think that's important because our goal at the end of all this is to be able to really do both. But the reverse is going to be super important, being able to be given the word form and to see the algebra in that word form. So that's what this next section is about. You're given words and you need to translate them into those algebraic expressions now. We're reversing. And we're starting with basic one operation translations. So it's important to remember that we're looking for coefficients, variables, and constants in our words that will help us to give us the translation. So, and your math term vocabulary for operations is key here. So you're going to need to study up operation terms to be able to translate successfully. So the first one says the product of 15 and a number. Well, if you don't know what product means, this is one of those math terms. If you don't know that that's the answer to a multiplication problem, you will not be able to set this up successfully. You'd be guessing. So it's important to indicate that, hey, this means multiplication. So I'm putting a little symbol up there just to indicate my expression is going to have multiplication in it, which means it's going to have a coefficient and a variable because these are algebraic expressions, and it says 15 and a number. So 15 is the coefficient and a number. There's your variable. Remember, we were translating the variables to those words. Well, now we're going to translate that to a variable. We're going to use n. We're going to let n be our number that's unknown. Okay, so 15n. Now, it's important that we pay attention to this box up here because we are required to use proper algebra notation. We do not put a symbol in between the 15 and the n, and it still means times, 15 times n. So if you were to enter that informative with a symbol in between, or to put the letter first and the variable second, the variable first and the coefficient second, like this, 15n, you would be marked incorrect. So these forms will not be marked correct informative. You have to have it in its proper final form. All right, the next one, it says the sum of a number and 5. Sum is the answer to an addition. And if you don't remember that that's the answer to an addition problem, then you're sunk on this one. You got to know that. So the sum of a number, there's your variable, and there's where your plus sign goes, 5. And this next problem says it's the difference between a number and 8. Difference is the answer to a subtraction problem. So it's simply a number, that's your n, and then your and 8. Quotient, the quotient of 12 in a number, quotient is division. Put a little mark up there just to remind me that that's what that operation is. And again, in the world of algebra, we're reminded proper notation at the end when you enter that answer in the formative has to be in the form of a fraction to be considered algebraic. So we've got the quotient of 12 and a number. So it's 12, then your division symbol and a number. All right, so that gets us started on those one step. Here are some other examples. Double a number. You have to know that doubling means to times by 2. So I'm just putting a little indicator above, a note to myself. That means to times by 2. I'm taking some number n and I'm multiplying it by 2. And I'm using proper algebra notation. I'm putting the coefficient 2, the double, and then the n with no multiplication symbols in between. This one is 18 minus a number. Minus, well, that should be obvious as subtraction. 18 minus a number n. And then a number increased by, so we start with the number and we increase it by 11. And then this one is a number split equally 5 ways. That means division. So n over 5 in the fraction form. Okay, and then when we're looking at these expressions that are coming up, we have to watch out because we need to reverse the order that the number and variable are given to us in the expression. So the first one reads 5 more than a number. So on this one, a lot of times students will translate this as 5 and then they know more than is addition and they'll say it's 5 plus a number, and that is incorrect. So when we see the words more than, we need to, and we're reading this 5 more than some amount, we need to start with the amount n. We have to start with the amount we're given, and we need to go up 5 from there. So this would translate as 5n plus 5. This is not 5 plus n. So you have to recognize that it makes sense that to have 5 more than something, we need to have something first. We need to have an amount to start with, and then we have to go up 5 from there. We need to go up 5 from our start amount, n. This one, 3 fewer than a number. So similar to the more than, this says fewer than. And in order to know how much, when we have 3 fewer than something, we have to start with that something. So 3 fewer than a number, we have to start with the amount, the number, n, and then we drop 3 from there. We have to go 3 below that. So this would not be correct if you put it as 3 minus n. That's not correct, just like this one's not correct. You have to know that we start with the amount n and we drop 3 from there. 10 take away from a number. 10 taken away from a number. We're taking 10 away. That means it's minus 10. So it would become second in our expression. We'd start with our amount and then we'd take 10 away from it, minus 10. Not 10 minus n. So, and then this one says 20 added to a number. So that means we have to start with our number and we go up 20 from that number. So it would not be correct to translate this one as 20 plus n. We don't start with 20 on this one and go up n. We're not adding n to 20, we're adding 20 to n. So what I call this is the switcheroo. More than, fewer than, those pieces are telling you that you have to read for those and know that we're going to switch the order. The 5 came first, the variable came second. But that's not the order it translates in when you translate it to that algebraic math expression. 3 came first, but it comes second in your expression. The 10 came first, but it comes second. And the 20 came first, but it comes second in your expression. So you have to read for understanding that you know that order matters in math. And when you're translating these, you have to translate it in the order they're telling you to use in order to get it correct. So watch out for those switch words, and when you see them, just know you got to switch it around. All right, now we have two operations here again. So we need to be looking again for coefficients, variables, and constants, and using those multiplication, division, subtraction, addition terms, looking for those. So we have twice a number increased by 8. Twice a number, there's one term, increased by 8, there's a second term. Increased by is addition. Twice a number means you're going to multiply your variable by 2, and you get 2n plus 8. Proper algebra notation here. I didn't write the times symbol in. I didn't put the 2 after the n. I put the n second. This is how you have to write this one, this piece right here. The difference of 8 and triple a number. Difference means we're subtracting. And it says the difference of, here's our term. We're subtracting this term and the triple a number term. So this term is 8. It's a constant. Your and is where that minus sign goes for the word difference, because it's subtraction. Answer to subtraction. And then triple a number is 3 times n without the symbol, because we're using proper algebra notation. The product, that means multiply. The product of 3 and a number squared. That means exponent. And it's a 2. So product of 3 and a number squared. No symbol in between, proper algebra notation. 12, take away the quotient of 6 and a number. So we start with 12. That's one of our terms. And we're going to take away, that's subtraction. Quotient is division, but we're not going to use that symbol. I'm just putting it there to tell me, hey, this is going to end up division. 6 and a number. 6 and a number. So if you just take it and read it carefully for those operation words, find your coefficients, find your constants, and put your expressions together with that variable involved. Okay, we've covered a lot of examples today. We've covered proper algebra notation, and we've covered those switch words you got to look out for. So right now it's your turn to see how you're doing on understanding what we've covered in this lesson. So these are one operation. Translate these words to algebraic expressions. And then you're going to turn the video back on to see if you got them correct. And then make sure you're paying attention for the multiplication division problems you're setting up, that you're following proper algebra notation when you write it. Turn the video back on when you're done with these 4 to see if you got them correct. Okay, so this right here, you should have gotten 7 minus n, because difference is subtraction. Product is multiplication, so you should have 8n, and it should have no symbols in between. The 8 has to be first, the n sitting right next to it. This one was 20 plus n, sum is addition, so 20 plus n. And then quotient is division, so it should have been a fraction bar for your division symbol, 20 over n. Following, again, that proper algebra notation. Okay, here are 4 more to try, and pay attention right here. It's a reminder that you have to read for understanding on that one. All right, so pause video, turn it back on when you're done to see if you got these correct. So you should have written 2n, just like that. No symbols in between. 2 is your coefficient, n is your variable, and that means we're multiplying. Because twice is doubling, it's multiplying by 2, so I just indicated that up here. And then this one, n to the 4th power, and it should be, an exponent up here, floating. And then this one right here, it should be n plus 5. If you have 5 plus n, you didn't read it for meaning. It's not adding n to 5, you're adding 5 to n. So you have to start with n and add 5 to it. And then this one, 18 divided a number of ways equally, is 18 over n as a fraction. All right, here are your next 4 to try. Pause the video and turn it back on when you are done. So this first one, you should have had the n first and then minus 15, because it says we're taking 15 away from this n. So we got to start with n and take 15 from it. This one is n plus 10. And then, because total is addition, more than, so 8 more than a number, means we got to start with that number and go up 8. So n plus 8, not 8 plus n, got to switch that one. And then this would be n minus 7, because we're taking, starting with 7 and we're starting with a number and we're going 7 less than that number. So that was also a switch. Okay, here are 3 problems for you to continue trying. These are 2 operations, so you want to make sure you're seeing both operations when you set it up. So this one would be 8 increased by triple a number. So we're going to start with 8 and then we're going to increase it by 3n. Tripling is multiplying by 3. This next one, a number cubed subtracted from, we're subtracting the number cubed from 10. So we got to start with 10 and we're going to subtract n cubed from it. So there you have that one. You can't have the n cubed minus 10. That's backwards. And then the difference between 3 times a number and 8. Here's your 3 times a number. And difference is subtraction minus 8. So this is the end of this lesson, and good luck on your assignment.